Hey guys, welcome back to robotics. So today we're gonna start talking about this dial thing right here. So inside your kit you're gonna have two of these, so go ahead and grab one of them and let's take a look. So first thing we see is that this blue thing has a dial that you can turn, okay? And then the other thing is that it's got three legs here. So let's go ahead and talk about what all these things are. Okay, so we have our three legs, and so I'm going to draw our potentiometer. Okay, looks like this, right? And then this is the dial here. And then we have three legs. All right. So these three legs, let's number them 1, 2, and 3. And in this case, you know what? Let me change it around. Let's put that one is 2 and this one is 3. And the 2 is going to be the one that is in the middle, okay? Another way to look at it, guys, if we turn it this way, where you're looking straight into the pins, it's going to look something like this. Okay, this is going to be 1, this is 2, and this one right here is 3. And then that one's the middle one. All right, I want to explain a little bit. Let me move this here. You guys can't see that. Okay. So let me explain a little bit as to how this thing works. So let's do a little bit of a word study, just real quick. This is potentiometer. And for me, I see two words here, potentio and meter. So potential, actually what it's referring to is the word potential. And when we think about potential, we think about energy or goodness or whatever useful, something useful that is in something, but it's not being used yet. So kind of like in life, when someone says, hey man, you got a lot of potential, that means that you have the ability to be great at whatever it may be. It could be some sport like basketball, it could be at math, or it could be at robotics, right? But you have a lot of potential, but it hasn't come out yet, right? So you got to work at it to have it come out. So that's what potential means in life. Now, when it has to do with electronics, potential is the same as voltage. Sometimes you'll hear electrical engineers say voltage potential, or use potential or use voltage. They're kind of interchangeable. And what that means is, how it relates to the real life potential is that voltage is energy, right? Is energy that is in something, but it's not being used yet, right? And once it's actually used, it turns lights on and things like that. So another way to think of it is like a battery. A battery that has charge in it has a voltage, right? It has potential, but it's not doing anything until you let that energy out. So that's kind of how those words are related. So potential in life is like energy or goodness that hasn't come out yet. Potential in electronics is voltage or energy that hasn't come out yet, but that will come out once we use it. Okay, now the meter. What is a meter? A meter is something that you can, that you can change. Maybe a few different meanings. Or another thing I think of is like a dial. Okay, so it's a voltage. So if you put it together, potentiometer is a voltage or energy that you can change, and that's what a potentiometer is. All right, so I just want you to kind of remember those two things. It's a voltage that you can change. Now, going back to these 3 legs right here, we have 1, 2, and 3. I'm going to draw a circuit here. And I'm going to call this VCC. Guys, remember that's a resistor, R1. And this is a second resistor, R2. And there's our G and D. So I'm going to draw lines here so we can label what these connections are. This right here, this connection is 1. This connection is 2, this one here. And this connection is 3. So the first thing I want you to notice is that inside here, the connection between 1 and 2 is what? It's a resistor, R1. In between 2 and 3 is a resistor, R2. Now, we won't go too deep into this right this moment, but what I want you guys to realize is that the question, which will help us actually use this, help our potentiometer be useful. The question that we want to ask is, what is the potential / voltage, because it's the same thing, at pin 2? Okay. Sorry guys, I gotta move my video here. Still getting used to this. Okay, so what is the potential at voltage 2? So what we're going to be doing is we will be using the noggin to figure out that question. So our noggin is going to be looking at pin number 2 and asking, what is the potential or the voltage at pin 2? And then what we need to do is we're going to connect pin 1 to VCC, which is another way of saying 5V on the noggin. And then pin 3, black triangle, we always use that for G and D. All right? So what determines the voltage at pin 2? I want to know what the voltage is. So the next question is, how do I know? How do I know what the voltage is? All right, well, it depends on 2 things, R1 and R2. All right, so if R1 becomes big, then pin 2 gets smaller. If R2 becomes big, pin 2, the voltage at pin 2 gets larger. All right, so we don't need to get into all the math right now, but the key thing to remember here is that the voltage at pin 2 depends on R1 and R2. So as R1 and R2 changes, the voltage at pin 2 right here is going to change. So, okay, so what does that do for us? Here's the thing. All right, there's a dial right here, right? What do you think it does? You know, just as I'm talking, as I'm explaining this, right? What do you think the dial does, right? Well, the dial turns back and forth. We know that, okay? Here's what the dial does. As you turn the dial, it changes R1 and R2 at the same time. Okay, let me kind of draw this. So if you notice, if you turn the dial, it doesn't turn all the way. I want to say it, let's see. Yeah, it turns, if you look at it, there's this arrow, little arrow there, okay? And if you try to look straight at the arrow, you can see that it turns something like that much. Okay, it can't go the full 360. So as you turn the dial, let's say it's right here. That arrow is right here. What's going to happen is that on one side of it, you have the resistor R1. On the other side of it, the remaining portion, okay, you have the resistor R2. R1 here, R2 here. So do you kind of see what's going on here? As I turn the dial, so if I turn the dial over here, R1 is going to suddenly get bigger and R2 is going to get smaller. Let me draw another example. Okay. If I put the dial over here, then what's going to happen, right? R2 becomes pretty small because that's all I got here. And then R1 becomes really big. So the main thing I want you guys to connect here is that as we turn the dial, the size of R1 and the size of R2 changes. And then if that's true, going back to our original question of what is the potential, looking at this right here, what is the potential at pin 2? Well, that depends on R1 and R2. So as we turn the dial, if we put it all together, as we turn the dial, the potential or voltage at pin 2 changes. Okay? All right, so you know what? Let's try to make some connections here. All right. So we want to connect our potentiometer to our noggin, and we have 3 legs, right? So the first thing is, let's figure out, remember, pin 2 is the middle one. 1 and 3, they're the ones on the side here. Okay. So pin 3 is the middle one. Sorry, pin 2 is the middle one. 1 and 3 on the side. Now, if you get 1 and 3 mixed up, like if you have it like this as opposed to that, it's okay. It's still, our circuit's still going to work as long as you make sure you know which one is pin 2. Pin 2 is the middle one. All right, so first thing is, let's put our potentiometer onto our board. Actually, I've already done it here, but let me do it again. So what we're going to do is put it on the board, and let's make sure we put one pin, each pin on its own row, okay? So I'm going to put it down here where I have, let me go with a larger view here. Okay, so I have a blank area right here. So each pin on its own row, like this, okay? Now, the way that I have it set up is that 1's going to be this row right here, 2 is here, and then 3 down here. So let's go ahead and make these connections. So 1, going back to my drawing here, 1 needs to go to 5V or VCC. So let's get a red wire. So 1's up here. This is going to go to VCC, so I can just, any of these V's over here, that works. Okay. A V row means 5V, okay? Then I'm going to do pin 3 down here. Needs to go to GND. So I'm going to use a black wire for GND. And there's a bunch of GNDs. Any pin on the G rows would be GND. It's got a whole bunch of options. I'm going to use this one right here. All right. And then the last one, pin 2, needs to go to somewhere else. I'll show you. So I'm going to use white here. You can use a different color if you want. Pin 2, we're going to connect to A0. Okay? So if we look closely, let me zoom in here. Okay. Over here on this side of the board, you're going to see A0, A1, all the way to A7. We want to put it into A0 on the S row for signal. Okay? There we go. So the A0 signal. All right. So pin 1 right here is to 5V. Pin 3 right here is to GND, and then this one right here is on A0, the signal row. All right. So now what's going to happen is as I turn this, as I turn the dial, the voltage at pin 2 is going to change. Now the voltage at pin 2 is connected to A0 over here. So in our code, we're going to program A0 so that we can read it out. All right, let's try this. All right, so we're going back. All right, so what we want to do is we actually want to read the voltage at A0, because remember we've connected the pin here, the pin 2, to A0. So how do we do that? We're going to use something called the serial monitor. So we can actually print out to our screen what the noggin is seeing. Okay? I'll show you how to do that. So we're going to start blank program, just simple so we don't get confused, all right? So blank program here. And we're going to do a void setup. Okay? In here, we're going to say serial dot begin 9600. Don't worry about why it has to be 9600. Just make sure you put 9600 right now. Okay? So we have serial dot begin 9600. All right. Next thing is we need a void loop. Void loop. All right. And we're going to do a simple test just to have our noggin say hello back to us. So we're going to say serial.println. We're going to do hello Ed. And we have these quotations around my sentence. Okay? One in the beginning here, and then one at end, and then we do this. All right, so what this is saying, this line right here is saying, I want you to say hello, comma, Ed, exclamation mark, through the serial monitor. And I'll show you what that looks like in a second. Now we're almost done. We have to right here add a delay 100. Where delay tells the computer to just hang out, chill there for 100 milliseconds before starting the loop again. The reason you want to do that is that you need to give it a little bit time between each hello Ed, because if it just says hello Ed, hello Ed, hello Ed nonstop without any delay, the software, the website kind of gets messed up. Okay, so if that does happen, you'll have to restart the website and all that, and so we don't want to do that. We want to slow it down with a delay 100 so that it doesn't crash the website. Okay, All right, so delay 100, and let's upload this. All right, and connect. Okay, great. Now, right now, you don't see A0 on here, nothing with a potentiometer, so it's not going to be reading the voltage at pin 2 on the dial yet. We're just going to test, though, if we can read something from the noggin. Okay, so at this point, we uploaded it, but I don't see anything, right? So what we need to do, you notice there's this monitor tab. So we're going to click monitor, and then you have to click here. There we go. And so it's just looping, hello Ed, hello Ed, hello Ed. Cool. And it says it's connected. Let's click here. That disconnects it, and let's go back. Just to make sure it's working, let's say, hello Ed, this is robotics class, and it can upload. So you can play around with that. This should work. It should be pretty basic change. Yeah, every time you need to click here to connect. Cool, it's working. All right, all right. So, just as we're doing this, I always like to give challenges, right? So challenge number 1 is print 2 messages to yourself. 2 different messages to yourself. So how would I do that? I can do something like this. Print ln. Hello Ed, this is robotics class. This is my second message. Hopefully you come up with something more interesting than that. Always put a delay 100 after. And so what will happen is going to save both of these 2 things. Okay, super easy. Let's make sure it works. Close, click the monitor, connect. There we go. We got both messages. Cool. I'm going to stop it by clicking disconnect and going back here. All right, so now that we know how to have our noggin say something back to our computer, let's talk about this A0 thing. All right, so what we need to do now is we're going to try to read the voltage at A0. How do we do that? We're going to say serial.println, and then I got to put something into here. So I'm going to kind of combine a few things that we've learned about. I'm going to create a variable. I'm going to create a variable called we're going to call this potentiometer. All right. And potentiometer is going to equal to analog read. Notice the camel case there with the A and the R. And then inside there, A0. All right. Key point, this is not AO. All right. It's got to be A0. So what it's going to do is going to look at analog read A0, which is this white wire right here, and put it inside potentiometer. Then I'm going to do a serial.println potentiometer. Okay. So it's going to print out whatever this is, and I'm going to do a delay 100. Okay, remember, always make sure you put that delay anytime we do the serial print.ln. All right, let's see what we get here. Connect. And then I'm going to do my monitor. Okay, it says 560, and I'm going to turn it. You see it's changing. So I turn it all the way to the right, it becomes 0. All the way to the left becomes 1023. So the maximum is 1023. The minimum is 0. And I can go in between, kind of change it around. All right, let's disconnect. So challenge number 2, guys. Print out 0 to 1023 using a 0 and potentiometer. All right, so just basically what I did right here, being able to turn it and get it go all the way to 0 and to 1023. Now, you might be wondering, I talked about the voltage at A0. Now, when it says 0, does it mean 0 volts? Maybe. When I say 1023, does it mean 1023 volts? No, it's not. Well, that's a lot of voltage, so it's not 1023 volts. So there's this translation or decoding that we're going to have to do. So we'll save that for another time. But basically, 0 is the same as 0 volts, and 1023 is the same as 5 volts. So to actually get the voltage, we're going to have to convert it. And so we'll look at that another time. But for now, what you're going to get is 0 to 1023. Okay, so we've got the potentiometer going. We're able to see 0, all the values from 0 all the way to 1023, and it depends on how we turn this, right? So let's do a little bit of something more interesting, all right? So I want to say, let's write a program. If A0 is less than like half, what's around the halfway point of this? It's 512, around there. If A0 is less than 512, print out hello. If A0 is greater than 512, print out goodbye. All right, so how are we going to do that? Well, we're going to have to use our if-else stuff, our conditionals. So let's go ahead and write that in. We're going to say, so we don't need this now. We're going to say if potentiometer is less than 512, put my curly braces. We're going to do something there. I'll fill that in later. Else, if potentiometer is greater than 512, we're going to do something in there. Okay, so go into our goal, right? If it's in here, if it's less than 512, we want to print hello. How do we do that? We need serial.println quotation. Remember, whatever you need to print has to go inside these double quotes, okay? Hello. If it's greater than 512, serial.println. Oh, not good bite, goodbye. All right. Not so bad, right? If it's less than 512, hello. If it's greater than 512, goodbye. All right. So what do we do here? We just made a really simple program. Hopefully it works. That where as we control the dial, the robot does different things. Right now it's just saying hello, goodbye, but we can add different things to that. in the future to make it more complex. Let's first make sure this works. Oh, I said there's a mistake. Oh, right here, misspelled. There we go. All right, let's try this out. Oh, press the wrong button. Connect. Okay, so it's saying hello right now, and I turn it to the left. It says goodbye. I'm going to turn it back to the right, and it says hello. All right. And actually, right now, what happened? You see it's just stuck. Let's see. You know what? I probably forgot to put the delay. And so this is good. This is what happens here. So I'm going to have to close this. Okay, and open it back up, and hopefully it'll work. So actually, it's not so bad I made that mistake, because maybe you might run into that same thing. All right, and of course my code's not there. So let me pause this and get my code back. All right, we're back here. So again, what I can do here is add my delay 100 after, and actually, just to make it more explicit, I'll put it after there. So after each serial print, okay? So let's see, if I do it this way, I shouldn't get that error anymore. Let's upload. All right, let's try this again here. There we go. All right, now I shouldn't get that error. Okay, and if you notice, earlier it was going a lot faster. That's why I think I forgot the delay. All right, so now it works. Hello, goodbye. It depends on how far I turn the dial. All right, cool. So let's go back there. So the last challenge, I won't write the previous ones. Last challenge will be if potentiometer is less than 200, say hello. Potentiometer is between, I can do it like this. It's between 200 and 512, say hi there. If between 512 and let's say 900, say almost there. If between 900 and 1023, say goodbye. So what you're going to have to do is you're going to have to add some more else ifs in here to make this work. All right, so as you turn the dial, you should see 4 different messages, and you should be able to go back and forth between the 4 of them. All right, so give that a shot. So that's our introduction to potentiometers. More on this next time. So right now, again, we're just printing messages, but the next step will be to use the potentiometer, like these numbers here, to actually control the motor. All right, that's it for now.